Hello friends, this is Deepak Kumar, Assistant Professor in Kite Group of Institution. In this lecture, we will discuss the concept of internal architecture of 8085 microprocessor. So these are the contents for today's lecture. First of all, we will discuss the features of 8085 microprocessor, and then we will proceed towards the internal architecture of 8085 microprocessor. So as we know that the 8085 microprocessor is the very first commercially used microprocessor. This is basically your 8-bit microprocessor that is developed by Intel. What do you mean by 8-bit microprocessor? 8-bit microprocessor means that it actually processes the 8-bit information at a time. So that's why it is known as 8-bit microprocessor. As we know that the microprocessors are digital in nature, so it actually required some power supply to operate. So plus 5 volt power supply is required for this microprocessor. There are 6200 transistors on a single chip is available in this 8085 microprocessor. It actually operates on 3 megahertz clock frequencies. In this 8085 microprocessor, actually 16 address lines are available. So these address lines are actually divided into two halves. The first one is the upper half part, that is from A15 to A8. This is 8-bit information, that is 8-bit upper half part, and the next one is lower half part, that is from A7 to A0. This is again 8-bit information. So this 16-bit information is divided into two halves. Out of these two halves, this lower half part will contain these 8 bits address information, as well as it also contains 8-bit data information. So we can say that the data information is multiplexed in these 16 bits address line. That means out of these 16 bits address line, this 8 bits information basically contain the address information, as well as it also contains the data information. But at a time, it is not contain both the information. So that's why we can say that this 8-bit information will be considered as address line for a particular time, and in another time it will be considered as a data line. Okay, so that's why this is actually represented as AD7, because it contains address as well as data. So that's why it is represented as from AD7 to AD0. Okay, so that's why this 8 bits multiplex address and data bus it actually contains. The next one is it actually contains the 16 address line. So when this lower half part contain the address information, then this address will be considered as a 16 bits address information. If the size of address line is of 16 bits, that means 64k bytes of memory can be utilized by this 8085 microprocessor. It actually generates 8-bit input output address, hence 2 to the power 8, that is 256 input output ports can be supported by this microprocessor. This microprocessor also handle the external interrupt. There are 5 types of external interrupts are available. That is these 5 different types of interrupt. It also provides the facility of DMA, that is direct memory access. That means when some external devices wants to access the address as well as the data bus of this microprocessor, then it is possible in this 8085 microprocessor. So these are some basic features of 8085 microprocessor. Now we are just moving towards the internal architecture of 8085 microprocessor. So this is your internal architecture of 8085 microprocessor. What do you mean by internal architecture? That means how the internal working is performed by this particular microprocessor. What do you mean by internal working? Internal working means how the data is transferred from one location to another location. Okay, what are the control signals are generated? So when we are studying about that, so that is actually known as the internal architecture of 8085 microprocessor. So when we are seeing this internal architecture, so this internal architecture is basically divided into some basic units. The first one is the register array. This will be considered as the register array. The next one is your timing and control unit, this one, that is the second important unit of this architecture. The third one is the instruction decoder and machine cycle encoder, this one. The fourth one is the interrupt control logic, that actually controls the external interrupt. This one is the serial input output control unit, by which we just perform serial input as well as serial output communication through external memory. The next one is basically your flag registers. Okay, so flag register and arithmetic and logic unit. So this particular architecture is basically divided into some basic functional unit. So if you are talking about the register array, so these are basically registers: WZ, BC, DE, HL, stack pointer, program counter. These are basically your register array. As well as we have some more registers, that is your accumulator register, temporary register, instruction registers, that are also used. Okay, so these registers are basically divided into two parts. The first one is known as the general purpose register, and the next one is known as the special purpose register. General purpose registers means the registers that are available to the programmer, that is for us. If we are accessing the particular register, that means that is your general purpose register. If we are not able to access a particular register, so that registers are actually known as the special purpose registers. That registers are actually used by the microprocessor, and the general purpose registers are basically used by the user, or we can say that the developer, or we can say that the programmer. Okay, this basically timing and control signals are basically used to provide the control information to all the unit of this particular microprocessor. Either it is registers, either it is arithmetic and logic unit, either it is interrupt control unit. So it basically provides the control signals to all the particular component of this architectures. Internal interrupt control basically control the external interrupt. As I told you that this basically provide the communication, serial communication in between the microprocessor as well as the peripheral devices. This instruction decoder and machine cycle encoding basically decode the instruction. That means identify the meaning of a particular instruction. And this arithmetic and logic unit basically used to perform arithmetic and logic operations on a particular information. So these are some functional unit of this 8085 microprocessor. Now we have just discussed the working of this 8085 microprocessor with the help of an example. Let's suppose if we want to add two numbers in very high level language. So what we do, we generally use a variable, that is C, and here we just perform the addition of these two variable, that is first data is available in A, the second data is available in B. We just perform addition and the result will be stored in this C register, C variable. So when we are implementing this operation in 8085 microprocessor, so the language that we actually use is your assembly language, and we simply write only add B. When we have written add B, then it is understood that it is nothing but it is equal to A plus B, and the result will be stored in A. What does it mean? It means that it is very clear that whenever we perform any arithmetic operations, then the first operand will always available in this A register that we used over here, that is your accumulator register, that is represented by A. And the second operand is taken from this register B. We just perform addition and the result is again stored in this particular register A. Whatever the result that we obtain, that will be stored in this register A. So that is actually the meaning of this instruction. Okay, so that's why here in arithmetic and logic unit, the first operand is always available in this register A. So first operand is provided by this register A, and the second operand will be provided by this temporary register. And in this temporary register, the register B content is moved. Okay, so microprocessor basically execute the instruction in instruction cycle. Okay, so when we are talking about instruction cycle, so in instruction cycle we have three basic steps. So the first one is the fetch, the next one is the decode, and the next one is your execute. First of all, we just fetch the instruction from where? From main memory. Then we decode the instruction, that means identify the meaning, identify the OP code, that what actually instruction wants to perform. And after getting the information, after decoding it, the microprocessor execute that instruction. And after that, the next instruction will be fetch, it will be decoded and executed. After that, next instruction will be fetch, and the same sequence will be followed. Okay, so let's suppose if we have this memory, this is your main memory. So this basically contain the program information as well as it contain the data information. Okay, that is also available in this particular main memory, as well as it also contain the stack memory also. Stack memory is also available in this main memory. Okay, so how this instruction cycle is executed? So let's suppose here we have a set of instruction. Set of instruction is nothing but that is your program. So how can you differentiate between program and data? Let's suppose if we are using a WhatsApp. So WhatsApp is what? WhatsApp is basically an app. App means what? That is your software, that is your program. And the messages that are available in WhatsApp, that is your data. Okay, so here the execution is actually start from this program counter. So program counter basically contain the address of instruction that is actually fetch. Okay, so this program counter basically contains the address of very first instruction. So this address information is placed to the address bus. We just move toward this particular memory location and we just fetch the instruction. So this instruction will be fetch and this instruction will be placed to the data bus. As I earlier told you that the system bus basically contains the three type of buses: address bus, data bus and control bus. Address bus basically contain the address information, data bus contain the data information, and control bus basically contain the control information. So address information is placed to the address bus, the microprocessor will move toward this particular location and this instruction will be fetched. After fetching the instruction will be placed to the data bus and then it will move towards the internal data bus, and from this internal data bus the data will be moved toward this instruction register. That means now the instruction will be moved toward this instruction register. After that, this instruction will be moved toward this instruction decoder, which decode the instruction. That means find out what is the OP code of this instruction. That means what is the meaning of that instruction. So let's suppose this instruction is your add B. That means right now the microprocessor understand that this instruction is actually wants to perform add information. So after that, this decoded information is sent to this control unit. When this information is received by this control unit, then this control unit provide the control signals to all the components. Okay, so what it actually do, it will activate register B. It will tell this register that please provide your information. Then this register B will provide 8 bits information to this data bus, and from this data bus this information is moved towards this temporary register. Okay, and from this temporary register this information is moved towards this arithmetic and logic unit. So that is the content of register B, and we know that the first operand is always A. Then it will activate this accumulator and tells this accumulator that please provide your information. Then this accumulator register will provide their information to this arithmetic and logic unit. Okay, so now this arithmetic and logic unit basically have two operand, that is A, and from temporary register, that is the content of B, it will perform addition, and after addition the result will again store in this accumulator register. So this control unit again activate this accumulator to store the result. Then this result will be placed to this data bus, and from this data bus the result will be placed towards the accumulator. So this is the execution of one complete instruction. So first of all, the instruction will be fetch. How it will be fetch? It will be fetched by this program counter informations. We will move towards this memory location, fetch the instruction, and then we will execute it. Okay. So when the first instruction is fetch, after fetching the instruction, the program counter value will automatically incremented with the help of this incrementer and decrementer address latch. So after that, after fetching this instruction, the program counter is basically pointing to the next instruction. So now the same procedure will be followed for this instruction also. And after completing of this instruction, the next instruction will be fetched, and so on. So in this way, the instruction will be executed with the help of this 8085 microprocessor. Okay, so here we just understand what is the meaning of arithmetic and logic unit. We just understand what is the meaning of this instruction decoder and machine cycle encoding. What is the meaning of this register array? What is the meaning of this timing and control unit? Okay, interrupt control unit basically used to control the external interrupt. So if there is some external interrupt, so that interrupt will be handled. That means that interrupt will be acceptable or not acceptable. Okay, so all these information will be controlled by this interrupt control unit. Here we have flag flip-flop also. It basically provides the status of this result. After arithmetic and logic operations, whatever the result will be available, so that result is 0 or non-zero. That result will contain carry or it is not contain any carry. Okay, so how many parity bits are available? So all these status will be identified via this flag flip-flops. Okay, so flag flip-flop is what? It basically provides the status of the output of arithmetic and logic unit. Okay, whatever the result is available, so what is the status of that result? Is it 0? Is it non-zero? Is it positive or is it negative? All these information will be represented by this flag register. Okay, here we have address bus buffer and data oblique address bus buffer. As you know that the address basically contains 16 bits information. So that's why this is stack pointer, program counter, what it contains? It contains basically the address. So that's why its information is of 16 bits. Okay, so we know that the 16-bit information is divided into two parts. Out of these 16 bits, 8 bits will be used as a data bus also. Okay, so, but at the same time it will not contain the address information as well as the data information. For some particular time, this 8-bit will be considered as an address bus, and for some another time this 8-bit will be considered as a data bus. Okay, so this is basically the meaning of this address bus buffer and data bus buffer. So this is all about your internal architecture of 8085 microprocessor. So these are the references for this particular lectures. So in next lecture we will discuss the concept of pin diagram of 8085 microprocessor. So till then, thank you so much.